Today we're going to start by talking about logarithmic equations, how to solve logarithmic equations. And before we get going, keep in mind that you should be counting the number of brain and hand appearances. This does not count as an appearance, but this is the brain and this is the mini hand. Yeah, I know it's creepy, I'm sorry. So count the number of times you see the brain, count the number of times you see the hand during this recording. So the first property we're going to look at is solving logarithms when you have a log on both sides of the equation. And all of the examples we're going to do today, we have a log on both sides of the equation. If you have logs on both sides with the same base, log base b of x equals log base b of y, then x must equal y. Kind of like with exponentials, if the bases match, then the other stuff has to match. So in number 9, log base 4 of 3 equals log base 4 of 2x plus 5. The log base 4s match, so the stuff inside the logs must match. 3 must equal 2x plus 5, and then solve that equation. So we would subtract 5 on both sides, and then divide both sides by 2. Now, you might notice in the directions it says check for extraneous solutions. Remember, extraneous solutions are basically extra solutions. The issue is that you cannot put a negative number into a log. If you grab a calculator and try to do log of a negative number, it does not work. So make sure we have to check each answer to make sure that it doesn't create a negative number inside the log. So this is not going to change. That side's fine. This side, if we plug negative 1 in, 2 times negative 1 is negative 2. Negative 2 plus 5 is 3. So we're good. This solution is fine. If we plugged this in and it created a negative number here, then we would not be okay. We'd have to cross that off and say no solutions since there aren't any other solutions there. Pause the video and try to start number 10 on your own. Okay, if you're stuck, we've got ln of something equals ln of something else. Because the ln's match, the somethings must match. So x squared minus 4x equals 12. The problem here is we have x squared and x. This is not just a simple equation to solve. We are going to have to factor and solve. And when we factor, we must have one side equal to 0. So we need to subtract 12 on both sides. And when we factor, we're looking for two numbers who multiply to give us negative 12 and add up to negative 4. Do you remember this? So think about ways to multiply to get 12. You've got 1 times 12, 2 times 6, 3 times 4. 2 and 6 could give you negative 4 if the 6 was negative. So positive 2, negative 6. That is the factored form. Once you have it factored to solve, what number plus 2 would give you 0? Negative 2. What number minus 6 would give you 0? Positive 6. So basically it's the opposite of the numbers in the parentheses. So these are our two potential solutions. We have to check for extraneous solutions. So we need to try negative 2 squared minus 4x, and you can probably do this in your head. Negative 2 squared is positive 4, minus 4 times negative 2. 4 times negative 2 is negative 8. So 4 minus a negative 8 would be positive 12. Try 6. 6 squared is 36. 36 minus 24 is 12. Both of these create positive numbers inside the log, so both of them work. So you're checking these in the original logarithmic equation to make sure that it doesn't create a negative number inside the log. Moving on to number 11. You'll notice this time there's actually 3 logs in the equation. So we need to use the properties of logarithms that we practiced for a couple days, expanding and condensing, mainly condensing. If you see addition between 2 logs, that's going to result in multiplication inside the log. So the x plus 2 and the x minus 3 become multiplied inside a log, and that equals log of x plus 29. Okay, what base is this log? If there's no base shown, that means it's base 10. The important thing is they're both the same. So because the logs are the same, the stuff in the logs must be the same. So x plus 2 times x minus 3, must equal x plus 29. We need to double distribute. So some of you already know the shortcut, but this is x squared, negative 3x, 2x, negative 6. Combine your like terms. The shortcut is add these numbers together. 2 and negative 3 is negative 1. That's what's in front of your x. Multiply those numbers together. That gives you the negative 6. Again, we have x squared and x, so we need to factor and solve. So we're going to get one side equal to 0. So x squared minus 2x minus 35. And now we need to factor and solve. We're looking for 2 numbers that multiply to give us negative 35. Those same 2 numbers need to add up to negative 2. So think about ways to multiply to get 35. You've got 1 times 35, 5 times 7. If we did 5 and negative 7, that would add up to negative 2. So positive 5 and negative 7, which means our solutions are negative 5 and 7. These are potential solutions. We need to check these back in the original problem. I'm going to check 7 first. If I do 7 plus 2, right here, 7 plus 2, that's a positive number. 7 minus 3, that's a positive number. 7 plus 29, that's a positive number. So that solution is fine. Now let's try negative 5. What is negative 5 plus 2? Negative 5 plus 2 is negative 3. And grab your calculator right now and try to do the log button of negative 3. If you push your log button and type in negative 3 and hit enter, your calculator is going to tell you error. You can't do the log of negative numbers. So because negative 5 will create a negative inside this log, it will also create a negative inside this log. It's not going to work. I do want to show you a quick trick. If you have a graphing calculator, you can actually put the left side into y1 and the right side into y2 and check this. So log of x plus 2 plus log of x minus 3. And then in y2, put log of x plus 29. Where these things meet is going to be the solution to the system. And somebody messed with this window so you can't see it. So there's the left side. and then the right side is in red. And notice they meet at one place at an x value of 7. When x is -5, notice the blue one doesn't exist over there, so there can't be a solution there. So this is a great way to check your two solutions to see which one is a solution, which one is not a solution. It's a way to visualize it. Number 12, we have to start with condensing. I see 3 logs here, so we need to condense. There's our equal sign. So we've got log base 2 of x plus 5 equals log base 2. Subtraction between the logs means division. So this means x minus 1 is on top and x plus 1 is on the bottom. Condensing is done. Now, log base 2 of stuff equals log base 2 of stuff, so the stuffs have to be equal to each other. So x plus 5 has to equal x minus 1 over x plus 1. This one's kind of weird, but if you remember proportions, anytime you have fractions and an equal sign, you can cross multiply. So x minus 1, that'd be this one, equals x plus 5 times x plus 1. I want you to try to finish this on your own. So double distribute, FOIL, whatever you call it. Get 0 on one side, factor, solve, check your solutions. Okay, multiply it out. We've got x minus 1 equals x squared. 1x and 5x would add together to give us 6x plus 5. Get 0 on one side, so we're subtracting an x on both sides and we're adding a 1 on both sides. Then we're factoring. We're looking for two numbers that multiply to give us 6 and add up to 5. That would be positive 2 and positive 3. From there we solve. Our x values are -2 and -3. Now we have to check both of these in the original equation. Not anything down here, back to the very original. So check the first one, -2. -2 plus 5 would be 3. That's positive, so that's good. -2 minus 1 would be -3. We can't have log base 2 of -3, so that is an extraneous solution. Check -3. -3 plus 5 is 2. That's okay. -3 minus 1 is -4. You can't have a negative inside the log, so that's an extraneous solution. What does it mean if both of your solutions are extraneous? It means there are no solutions. And here's a way to check if you are correct. I put the left side, log base 2 of x plus 5, in y1. I put the right side, log base 2 of x minus 1 minus log base 2 of x plus 1, in y2. And now I'm going to graph and see what happens. So here's my left side, log base 2 of x plus 5. And then in red, it will draw my right side, log base 2 of x minus 1 minus log base 2 of x plus 1. Do those two things meet? They do not. Because they don't cross, that means there's no solutions. So that verifies that what you got here is indeed correct.